Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at the subject software engineering. For today's session, we will be looking at object-oriented design. Some of the learning objectives of today's session include, because of object-oriented design, we may have to create a system from the requirements model, to comprehend the nature of design patterns by understanding very simple examples, to evaluate the design for applicability and reasonableness. When we wanted to study about the entire software development lifecycle or the program development, the creation of software involves basically 4 steps. One is on the establishing the requirements, which is nothing but the analysis phase, creating a design phase, implementing the code, development phase, and testing the implementation, which is testing phase. So, these activities are not strictly linear, they can sometimes overlap or they can interact with each other. We have looked at more of the requirements on what is to be collected as a requirements. Now that we are into the design phase, where we will talk about how. So, a software design specifies how of a program will accomplish its requirements. So, any requirements which has got what kind of, and now it has to be transformed to how it is to be taken to implementation. So, that is a software design determines how the solution can be broken down into very manageable pieces or modules. So, what each piece will do, it will carry that information of what each of the pieces should do. I have given a simple illustration of the software design in terms of representing it as a plant. If you look at the principles of this software design, basically this should be very flexible, and this also takes care of correspond to analysis model, programming paradigm, uniform and integrated, ensure minimal conceptual errors, represent correspondence between software and real world problems. It also has to look after code reuse, and it has to develop prototyping. When you look at the typical of object-oriented design, an object-oriented design determines which classes and objects are needed. So, we are about to define classes and objects when we are about to create the program, when we are about to implement on the program. Classes and objects are needed and specify how they will interact. So, low-level design details include how individual methods will accomplish their tasks. Here we tend to basically identify the classes and objects. The core activity of object-oriented design is determining the classes and objects that will make up the solution. Whenever we are about to implement on the problem that has been given, if it is being understood as what, converting into how, we will convert it in terms of classes and objects. So, classes are part of class library, reused from previous project, or it can also be rewritten. One way to identify potential classes is to identify objects discussed in the requirements. Objects are basically nouns, and services that an object provides are generally verbs. So, methods can be a verb, an object is generally a noun. If you look at this simple requirement, or one paragraph taken from the basic requirement that a document has, when I read through the entire document, the user must be allowed to specify each product by its primary characteristics, including its name and product number. If the barcode does not match the product, then an error should be generated to the message window and entered into the error log. The summary report of the transactions must be structured as specified in a specific section. So, this is part of the requirements document, and now that we wanted to convert it into a very good design by defining the objects. So, the nouns that are quite distinguished or quite predominant of this paragraph are having highlighted. So, to identify the objects, or there are certain guidelines in order to discover objects. This limits responsibilities of each analysis class. Use clear and consistent names for classes and methods. keep analysis class very simple. When looking at the responsibilities are pretty much limited. Each class should have a clear and simple purpose for existence. Having classes with too many responsibilities make them difficult to understand and maintain. A good test for this is trying to explain the functionality of a class in a few sentences. As a design progresses and more feedback is obtained from the potential end users, the trend of a project is to become more complicated. So whenever we start with a project, we clearly distinguish between a class, object and a method, but then as the design progresses, as and when we try to get more of the feedback, then there is a possibility of it getting more complicated. So therefore it is probably good to have very limited and tiny objects. It is still possible to play out a tiny class in your project and later decide that it can be merged with other classes. In order to have a clear class, object and method definitions, we may have to use clear and consistent names. Classes and methods should have suitable names that are very much appropriate to this given scenario. Class names should be nouns. Not finding a good name could mean the boundaries of your class is too fuzzy. Sometimes we may not be able to understand the clarity of why we have defined this class at this level. Having too many simple classes is okay if you have good and descriptive names for them. And the point that we have already mentioned, keeping class simple. In the first step, your imagination should not be crippled with worrying about details like object relationships. So you should never worry about the kind of relationship that we are about to establish between objects. Rather, it should be like whether we can take a particular noun or a particular verb as an object. Remember that the class represents a group or a classification of objects with the same behavior. Generally, classes that represent objects should be given names that are singular nouns. For example, we can give it like coin, student, message. Let us not establish the relationship between a coin and a student and a message. So individually defining singular nouns, we put it as objects. So a class represents the concept of one such object. We are free to instantiate as many of each object as needed. Sometimes it is very challenging to decide whether something should be represented as a class. For example, should an employee address be represented as a set of instance variables or as an address object? If suppose I look at an employee's address, the address might include street name, area code, area name and city, district, all the other factors. So should that be considered as an instance variable or it should be taken as address as an object? So the more you examine the problem and the details, more clear the issues become. So when you look at address as an object, it becomes very simple and we take all the values together. But then when you wanted to make it very complex, the issues will propagate. When a class becomes too complex, it often should be decomposed into multiple smaller classes to distribute the responsibilities. We want to define classes with proper amount of detail. For example, it may be necessary to create separate classes for each type of appliance in the house. If you define as like address that we have mentioned already, if you are about to define an appliance of a house, there could be a lot of utensils that will be available as part of the appliances. You can never mention all the things as a separate class. Instead, you can define it as an object and you can map it to a class. It may be sufficient to define a more general appliance class with appropriate instance data. Hence, it all depends on the details of the problem being solved. So the basic intention of getting into design is to make the complex problem into simpler ones by redefining it into very simple modules. But then again, if you are trying to make it more complex than the actual problem, then our problem is never been solved. So part of identifying the class, we need is the process of assigning responsibilities to each class. So now that we have defined a specific class, and we may have to define on the responsibilities of each and every class. The next activity being the creating behavior. So we may have to describe behavior for each and every activity that has been listed. So every activity that a program must accomplish must be represented by one or more methods in one or more classes. So every activity that I am trying to highlight in a particular problem need to be clearly defined in terms of the behavior, and should be represented as one or more methods in one or more classes. So we generally use verbs for name of methods. In early stages, it is not necessary to determine every method of every class. Begin with primary responsibility and evolve the design. So in the beginning of the design phase, we may not be able to appropriately mention the primary responsibilities. We can start defining on the design, but then as and when time goes on, we may have to define the individual behavior and its responsibilities. So the set of methods also dedicate how your objects interact with each other to produce a solution. So to define the exact behavior of this design, we draw sequence diagrams which can help tracing object methods and interactions. So between functionalities defined, how each and every functionality is getting interacted by themselves. So that can be tracked by use of drawing sequence diagrams. Consider this example. This is how we may define a sequence diagram. I have got a customer and 4 functionalities clearly been defined, like login screen, security manager, and there are users. Initially, a customer is trying to log in by the help of a login screen, and this login user ID and password is being validated, which validated along with the user by checking the user details, and the user details are fed back the validated data and the result being given to the use case model. So this is a sequence which happens as a flow from the customer to the user level. Say whenever a customer is willing to log into a particular page or a website, there will be a login page which says user ID and password. The login user ID is validated. User ID along with the password, corresponding password will again be validated, and those will be happen in parallel, but then the sequence will show only the arrow marks, which is in linear, shows how it progresses through, but then the dotted lines doesn't been replicated in the sequence diagram. It's an internal validation that happens within the system. So now that we may have to define 2 different design paradigms that we are about to use very closely when we talk about design. One is on the coupling, the other one is on the cohesion. So when we are about to design a system, 2 important things that play a vital role between the modules. One is called coupling. The other one would be a cohesion. Cohesion is nothing but the strength of individual modules that we have developed. Say whatever that we have seen, like classes, objects, methods that we have produced, all of them are talking about making it more simpler rather than producing it in a complex format. So the functionalities of each and every module that we are about to provide in terms of classes need to be more pronouncing, or it should be very strong enough. So that tends to be the definition of a cohesion. Whereas when it comes to the interaction between 2 different modules or 2 different simple applications, then there need to be high coupling. So when we talk about a complete system, we talk about these 2 terms in large. One is on the cohesion and the other one is on the coupling. The cohesion of a particular module need to be very high rather than the coupling. So, for each and every activity, say for example, to find a particular student detail, I should not be able to mention, say I am trying to validate as like the sequence diagram what we have seen. If you look at a particular student details from the database, to fetch a particular detail from the student database, I will not be entering the student's name, student's department, student address to fetch one's particular student detail. Rather, I might be mentioning on the roll number of the student, which will completely take out all the details from my database, mentioning the name of the student, the address of the student, the degree under which the student studies. All the details can be easily taken up. So, this system has got high cohesion and a low coupling. So, we may have to design systems in such a way that the system should have high cohesive activity rather than coupling activity. So, when we look at the cohesion between methods, methods of an object should be in harmony. If a method seems out of place, then your object might be better off by giving that responsibility to somewhere else. For example, we might get position, we might get velocity, get acceleration, get color, which are the responsibilities talking about position, velocity, acceleration and color. So, and it has been appropriately mentioned as get position, get velocity, get acceleration and get color. So, how are we to name the methods? So, use clear and unambiguous method names. Having good names may represent other to have a need for documentation. Many a times we look at people who develop the programs. The first program if they develop, they write it as program 1 or first program. The second program they develop program 2 or second program. At later instances, if we want to search for a particular program, appropriate name being mentioned for the file name would reciprocate for the easiness of identification of what kind of program we did, rather than program 1 and program 2 may not mean appropriate in terms of names. So, methods also should be considered in the same way. We may have to produce good names that may prevent others to have a need for documentation. So, in the documentation I should not be able to replicate saying that program 1 is for say palindrome and its structure purposes and program 2 is for some application which need not be detailed. Rather, it can be very specific that we need not explain about the topic of the or the file name of the program, rather than the complete flow of the program can also be documented. If you cannot find a good name, it might mean that your object is not clearly defined, or you are trying to do too much inside your method. So, when you are trying to do too much inside your method, that makes it unnecessarily complex. Rather, if you cannot define a correct name for the method, you are again making it trivial. Static class members. Recall that a static method is one that can be invoked through its class name. This you would have studied it when you are studying about Java or object oriented programming. For example, the methods of math class are static. Result is equal to math dot square root of 25. Variables can be static as well. Determining if a method or a variable should be static in an important design decision. We declare static methods and variables using static modifier. It associates the method or variables with the class rather than with an object of that particular class. Static methods are sometimes called class methods and static variables are sometimes called class variables. I can give you an example of that in later instances, but then we look at what static variables regularly mean. Normally, each object has its own data space, but if a variable is declared as static, only one copy of variable exists. Say private static float price. Memory space for static variable is created when the class is first referenced. All objects instantiated from the class share its static variables. Changing the value of a static variable in one object changes it for all the other objects that are within this particular class. If you look at this specific example, I am defining a helper class, public static int cube integer format of number, return number multiplication number multiplication number. So because it is declared as static, the method can be invoked as the value is equal to helper cube 5. So helper cube 5 would say 5 cube. Talking more about static class members, static methods and static variables often work together. If you look at the following example, this example keeps tracks of how many objects have been created using a static variable and makes that information available using a static method. Further, for a class, we can define class relationships. If you are very clear with understanding on database management system, we would have seen entity relationship diagram where we would have said aggregation, generalization examples, and with specific to object orientation we have inheritance relationships. So classes in a software system can have various types of relationship to each other. There are three of most important common relationships are dependency, which are represented as users. So when I have two modules, A uses B. When I have two attributes, I can use it as A uses B or an entity. Aggregation meaning A has a B. Inheritance meaning A is a B, which is supposed to be a generalization format. So when we are about to create dependency relationships, a dependency exists when one class relies on another in some way, usually by invoking the method of other. We don't want numerous or complex dependencies among classes. So making it more complex doesn't solve the purpose. So nor do we want complex classes that don't depend on others. A good design strikes the right balance. So we should have a very good appropriate dependency that should be mapped. Some dependencies occur between objects of same class. A method of same class may accept an object of the same class as a parameter. For example, the concat method of the string class takes a parameter another string object, say string 3 is equal to string 1 dot concat of string 2. So which means we are creating three different strings in one particular line. So this drives home the idea that the service is being requested from a particular object. So that is more about a dependency which rather has been mentioned as uses. So here we are going to talk more on the aggregation perspective of it. An aggregation is an object that is made up of other objects. Therefore, aggregation has a relationship, that is, it can be mentioned as a car has a chassis, a video camera has a tripod. So likewise, in the software, an aggregate object contains references to other objects as instance data. So the aggregate objects is defined in part by the objects that make it up. This is a special kind of dependency. The aggregate usually relies on the object that compose it. If you look at this very simple UML diagram that I have represented, I have created a student which has first name, last name, home address, school address, and if you look at the address in turn has got a lot of other attributes. So we might have an address entity separately which includes street, street address, city address, state zip code, and this has a relationship with the student. So student has a relationship with address as a separate entity. And the third dependency that we are about to create is on the inheritance part of it. Classes with a set of similar attributes and operations may be organized into a hierarchical relationship. So all of these dependencies that we are about to see are part of the hierarchical relationship. Common attributes and operations are factored out and assigned to a broad superclass, which is supposed to be a generalization which has is a relationship type. Superclasses are ancestors, subclasses are descendants. A class can be iteratively refined into subclasses and inherit the attributes and operations of the superclass. I can take you out with an example. If I am trying to define a superclass with 3 different hierarchies like class, attributes and operations. Say for example ball, the attributes of ball include radius, weight, etc. and the operations include throw, catch. And when I look at the subclasses, this ball can be a football, baseball or a basketball. And when I look at the attributes of football, it moves on air pressure, baseball liveliness and basketball air pressure and dimpleness. And the operations that I perform with the football are pass, kick, handoff, baseball are as mentioned. But when I go top on the hierarchy, which is supposed to be a superclass, I perform a generalization, and when I go bottom on the hierarchy, I prefer specialization to be done. So this has more of is a and has a relationship. Class design principles. We have solid principles of class design, a single responsibility principle which is SRP, open closed principle which is OCP, Liskov substitution principle which is LSP, interface segregation principle which is ISP and dependency inversion principle which is DIP. So most of which is followed in the agile practices. So single responsibility principle has a class should have one and only one reason to change. Say for example, can't you do anything right? This question is being posted to a software engineer or an author or a newspaper editor, and anything that one need to be right is checked out with an employee. Say calculate pay, report hours, writing employee on a payroll scheme. Open closed principle, where we have a principle which states that we should add new functionality by adding new code, not editing the old code. So anything that we might need to create it on our own, we should add new code to it, not by taking out, or reusability of the code is not been majorly possible. So abstraction is the key here. So I have given examples of this open and closed principle. Liskov substitution principle, all derived class must be substitutable for their base class. This principle guides us in the creation of abstractions. So LSP guides in the creations of abstractions. So derived class must be usable throughout the base class interface without the need for the user to know the difference. The other format of solid design principle is dependency inversion principle, which tries to avoid deriving from concrete classes. Associating to concrete classes is being avoided. Aggregating concrete classes, dependencies on concrete classes is also being avoided. And the other principle is interface segregation principle, which is sometimes class methods have various groupings. These classes are used for different purposes. Not all users rely on all the methods. So this lacks cohesion. This lack of cohesion can cause serious dependency problems. So we may not be completely dependent on the cohesion perspective. So those problems can be refactored. So we have looked at 4 different design class principles, which are OCP, LSP, DIP and ISP, where OCP discussed on the extend function without editing code. LSP discussed on the child instances substitute cleanly for base, and DIP depend on abstractions instead of the complete details. ISP split interfaces to manage the dependencies. In summary, in this particular session we have started looking at design principles, particularly on the object oriented design principles. So as I have started with saying, we will be discussing more on how of the system rather than talking about what. So now that we know what of the system, and we are trying to start with the how of the problem. So object oriented design determines which classes and objects are needed and specifies how they will interact. And further we have started describing about the guidelines for discovering object, classes and methods. So this is to just keep in mind, this is to limit our problem with minimal working on minimal modules. So limit responsibilities of classes, methods and objects, and we have started defining on the relationships like dependencies, aggregation, generalization, specialization, which is part of inheritance. Dependencies, we had users relationship, aggregation we had has a relationship, inheritance we have is a relationship. And finally, we have seen on the class design principles, which are explained as SOLID principles. Thank you.